Hi there, everybody. Thanks for coming to the webinar on the future of manufacturing in Europe. So my name is Marc Verbenkov. I am working with Bax & Company, and I'll be your host today. I see that we have a number of attendees here. Just a few points of housekeeping while you also look at the agenda. So we will be recording, and all attendees have been put on mute. You will be sent a recording later on, so don't worry about that. Also, at the end of each main speaker presentation, we will have a 5-minute period for questions. So you can add a question into the Q&A chat, which you should see in the Zoom webinar. There's also the option to raise your hand. And during that period, I will be able to unmute you, and you can ask a question directly to the speaker if you so wish. So there will also be a final Q&A session at the end, just in case anybody else has any other questions. And finally, all speaker PowerPoints will be made available with the recording in the next few days. So hopefully everybody's had a chance to take a look at the agenda. This is what we'll be doing. We'll have the 3 main presenters. I will start off with a little kickoff, and then we will conclude with some Q&As. So firstly, I just wanted to kind of introduce the company that I'm working with. This is Bax & Company Consulting. So it is a strategy consultancy that supports clients all across Europe in many different open innovation activities. So principally, we work in fields related to global societal challenges, covering areas like future mobility, advanced materials, circular economy, and of course, what's relevant for today's webinar, Industry 4.0. I personally work with a number of colleagues in our dedicated Industry 4.0 department, where we set up and run a lot of EU projects on technologies like collaborative robots, which we'll be hearing about a little bit further today, smart manufacturing, as well as exoskeletons and a number of other technologies. And what we really try to do is try to support the adoption of these technologies by European SMEs, as well as trying to understand the societal impacts of these technologies. So to start off really today, I wanted to kind of give a little bit of context for why this webinar was set up. So I think as all of us are aware, we know of Industry 4.0 and the kind of digitalization that's leading to more efficient and flexible manufacturing. Also, one of the kind of main technologies that has been getting a lot of attention in the past number of years within this trend has been collaborative robots, or cobots, as many of us call it. This is really seen as kind of one of the next technological pushes, specifically within flexible manufacturing. So I'm also assuming that most of the audience here is at least familiar with this technology, but very, very briefly, for those that aren't, this is a 2nd generation industrial robot that allows the technician to work next to a robot or even on the same tasks due to various motion and force sensors that detect the human interactions. So this is really opposed to kind of the blind industrial robots of the past, which, though very efficient and precise, do not really offer the opportunity for a manufacturing process to be highly flexible, which, as I mentioned, is becoming much more relevant in our modern manufacturing age. So also connected to the project that our 3rd speaker, Ger, will talk about in this webinar, we also validated many of the claims being put forth about cobots with many experts across Europe. There might even be an attendee or 2 that was part of that study that we did. And this was really in an effort to help find a more specific fit for businesses wishing to implement cobots, which I will briefly share in this brief kickoff, and then we'll move on to the presenters. So also beyond this, for the reason of this webinar, we also felt that it would be really valuable and interesting to showcase some of the more overreaching ideas that are being researched and presented by organizations like the JRC, as well as the larger support network that the digital innovation hubs provide to the important SME base across Europe, which our first 2 presenters will discuss. So very briefly, before we get into the speakers, I did want to touch a little bit as to what the cobot market information is about. So taken from the International Federation of Robots back in 2018, we can see that there were only some 14,000 to 20,000 cobots that were sold, which is about 3.5% of all total robots sold across the world. We also see that most of these cobots can be found predominantly in research, training, as well as exploring applications. So currently only 40% of collaborative robots are actually implemented in industry applications, which I think all of us can agree that this would show that there's a significant room for improvement for cobot applications to grow. Cobots are being predominantly uptaken by the electronics and automotive industries. However, a 2019 report did show that the logistics sector will be overtaking automotive in the next few years. However, perhaps more interestingly, there are many feasibility and kind of foresight studies that are showing that cobots will grow from 3% of the total robots to about 20 in the next 5 to 10 years, which I think is really interesting for all of us here that are interested in the kind of future of manufacturing. However, this growth is only possible if new markets are addressed by cobots, which is highly likely, as of course cobots really don't require an expert to train or to practically use. And I think that for this reason, and which we validated in the study that we did, industries such as food or other low automation level industries are really interesting and relevant for the uptake of cobots. And also, as Europe has many SMEs, it's mostly made up of SMEs across Europe, these organizations are highly suitable for the cobots to overcome many of the price and size limitations that cobots help with that. Finally, one of the kind of the main things that we took from this study was really the validation point of where specifically cobots fit in a number of these different industrial applications. So here's a list of some 8 relevant applications, palletizing being kind of the main industry application that's being used now and for the foreseeable future, with other ones such as assembly, machine trending, or even adding of sealants to be highly useful for the applications of cobots. So those were some of the kind of initial understands that we got from this market study that we did. If any of you are interested in hearing a little bit more about that, please get in touch with us after the webinar, but I really do want to pass it on to our speakers today. So I will briefly introduce all of our speakers, and then I will hand it off to Sergio, who is our first speaker today. So Sergio, he works as an economic and policy analyst in the Joint Research Center of the European Commission. His research interests lie in the area that exists between economics and sociology, focusing on topics related to social stratification and market or labor market dynamics. He has a PhD in sociology, and before joining the JRC, he worked at the Ministry of Health and Social Welfare of Spain as an analyst, doing social and market research in a private company. And Sergio today will dive into the current state of industrial automation in Europe and its impact on jobs and labor productivity. So before handing it off to you, Sergio, I also want to go over Minna's introduction. So Dr. Minna Lanz works as a professor of mechanical engineering at Tampere University, focusing on production systems and technologies. So her research interests are manufacturing ICT solutions, semantic modeling of manufacturing systems, and in robotics, especially human-robot collaboration. She's also a member of the Finnish Robotics Association, EFRA, the Vanguard Initiative, and EU Robotics, and of course actively contributes to visions and strategic research and innovation roadmaps originating from these networks. She's also published over 100 research papers, articles, and or book chapters. And her presentation today will focus on the potential of digital innovation hubs. And finally, Ger, he is a senior account manager at Flanders Make, a strategic research center for the manufacturing industry. So he has been at Flanders Make since 2008. Prior to this, he worked for 22 years at Philips Electronics in the manufacturing division. And Ger will present the COTEMACO SME support program that's allowing manufacturing SMEs to get hands-on experience with collaborative robots and other digitalization technologies. So without any further ado, I'd like to pass it on to Sergio, who will be talking to us about the JRC's research. So Sergio, if you want to take over.
Thank you very much for inviting me to this interesting webinar. I am Sergio Torrejón. I'm working in the Joint Research Center of the European Commission, and I'm going to talk about the impact of industrial robots on the European economy. I think it was a good decision to start with this presentation because I'm going to talk about macro effects. So this serves well to warm up and introduce the other panelists. First of all, and as an introduction, we have to take into account that the technological change is producing a lot of changes in the world of work in Europe, but also outside Europe. New technologies have destructive potential because new technologies, machines can replace human labor, but they also have a transformative impact because they produce changes in the task content of jobs. But also new technologies have a generative potential. I'm saying this because the use of new technologies in workplaces is associated to the creation of new forms of work, for instance, platform work. All these transformations are producing concerns among the population. As you can see here in this figure, an important share of the population is concerned about the negative consequences of technological change in the world of work and in the economy. 44% of the respondents think that their job could be at least partially automated by a robot or artificial intelligence. More than 70% of the population think that robots and artificial intelligence steal people's jobs, and almost 75% of the respondents think that artificial intelligence and robots will destroy more jobs than they will create. So, as you can see, there are a lot of people concerned about the negative consequences of technological change, but do we have good reasons to be worried? In order to ask to this question, our focus here is on the impact of industrial robots. It has to be clear that I'm not talking about any other type of technology on the European economy. First, on employment, on total employment. Then in the employment structure, this means unemployment, but by skill level or wage level. And finally, on labor productivity. As we can see here, the number of robots has been increasing a lot in Europe in the last decades. They have been around for a long time, for more than a century, but their deployment was intensified from the 90s. In fact, as you can see here, the number of robots in Europe in 2015 was 4 times higher than in 1995. This growth took place especially in Germany, but you can see the same dynamic in all European countries. The number of robots has been increasing a lot, but we also have to take into account that they are really concentrated. As you can see here, in terms of sectors, half of all European robots are installed in the automotive sector, and 73% are deployed only in 3 sectors: the automotive sector, rubber and plastics, and metal products. In terms of countries, as we saw, most European robots are installed and concentrated in Germany, but also in Italy and France. As a consequence, you can see that 27% of all European robots are concentrated in the German car manufacturing, in the German automotive, a sector that accounts for less than 1% of total employment. So, as a consequence, we think that this concentration limits the potential role that robots may have played in recent economic and employment trends in Europe. We think this because if we look at the descriptive data, but we are going to see if we can confirm this with some regression analysis and some econometric analysis. First of all, I'm going to try to answer to this question, do robots really destroy jobs? So I'm going to look at the relationship between robot use and total employment. And we have to take into account that the deployment of robots took place while most European countries were facing a process of deindustrialization. So the number of robots was increasing while the share of employment in manufacturers was decreasing. For this reason, there is a lot of people, there is still a lot of people that is blaming robots and other technologies for the job losses some industries are reporting. But is there really a negative relationship between robot use and employment? As we can see in this figure, the opposite is happening. There is a positive relationship between robot use and employment. And there is a positive correlation between the change in robot exposure and the change in employment rates. Now I'm going to show some details about this relationship. And I'm going to talk about the two studies. They both study what happened between 1995 and 2015. And first, we have a study published this year, several months ago, by Kleinert et al. They saw that there is a significant positive association between robot use and total employment. In technical terms, you can see that one additional robot per 1,000 workers is correlated with an increase of 1.3% in total employment. In absolute numbers, this means that one additional robot is correlated with 5 additional workers. So there is a positive relationship between robot use and employment, but we have to take into account that this association is small. Then there is another paper using a similar methodology. The first one is study the sectoral distribution of robots. This one is studying the regional distribution, but the findings are quite similar because they also find a positive effect for the full period. I'm saying here that we have to introduce some nuances to the debate because when they divide the full period, they find mixed evidence. But what is more important for our purpose is that when we are studying the full period that goes from 1995 to 2015, they both find a positive association between robot use and employment, and an association that is significant but small. So it has to be clear that we are talking about small effects compared to other trends occurring at the same time in the labor market. Let's talk about the financial crisis, globalization, changes in trade, etc. So consequently, we cannot expect a huge variation in terms of employment. The authors of these papers, my colleagues, think that this positive association could be explained because the use of robots produce reduction in cost, but also for the effects of some underlying variables such as their resilience, the competitiveness, or the innovative capacity of the industry is concerned. So considering that we find a positive effect that is significant but small, I think that the key lesson here is we have to highlight that these results do not concur with the popular narrative of robots destroying jobs at a large scale. Now, okay, we have just seen the impact of robot use on total employment. Now I'm going to show something about the impact of robots on employment, but by wage level. So I'm gonna look at the whole distribution of employment. And this paper of Anton et al. Find that robotization has a positive effect on employment that is slightly more pronounced for middle wage jobs. Here you have this figure only for illustrative purposes because I wanted to make clear that the effect of industrial robots on employment is positive for all terciles, but especially for middle wage jobs. That's why they can state that there is no evidence of robots producing job polarization for the period we are analyzing. In consequence, these results are important because they question the role of robots as a key driver of job polarization in recent decades. If you look at the specialist literature in the past, there are a lot of people blaming new technologies as the driver of job polarization, but we have some new results that are pointing in another direction. Finally, I'm going to say something about the impact of robots on labor productivity. And I'm going to talk about the research Jan Mittag and Pestole produced 1 year ago. They find that in a similar period, the period that goes from 1993 to 2015, the intensified use of robots contributed to the growth of labor productivity in the European industry. When they divide this full period in 2 sub-periods, they find that this positive effect is, there is a positive effect in both cases, but this effect increased from the first period to the second one. So this suggests that robots have to reach a critical mass in order to achieve their full beneficial impact on productivity. Of course, robots have a positive impact on productivity, but this effect is not homogeneous and varies considerably across industries. As you can see this in this figure, and you can see that the positive impact of robot use on employment is higher in transport equipment, rubber and plastics, and metal products. So we are talking about sectors with a higher density of robots. In contrast, we can see that the impact of robots on productivity is small in chemical products and other sectors. In summary, we have 3 key lessons. First, that we have seen that there is a small but positive effect of robot use on total employment. When we look at the whole distribution, we are seeing that robots does not produce job polarization because they are associated with a growth of middle wage jobs, especially. And finally, we have seen that robot use boost labor productivity. I have to say that for the impact of robots on employment, the results in the specialized literature are mixed, and the results are really sensitive to the model specifications, the assumptions, the period selected, the data used. So we have to take these results with caution. In any case, almost all papers are talking always about small effects. And in the case of the studies that analyze the impact of robot use on productivity, I can say that in this case, the evidence is more clear and all the studies go in the same direction. So as I am highlighting, the impact of robots in the European economy is rather small, but taking all findings together, we can see that positive effects seem to prevail. Consequently, it would be nice if we have to try to introduce a cautious note into the debate, because as we are seeing, these results don't fit this automation anxiety that we can hear sometimes on media. Always a lot of people talking about the disruptive impact of new technologies on employment, on the economy. For the moment, these results that are coming from a series of papers that has been published in the last year are not pointing in this direction. And finally, of course, these results have important policy implications. First of all, if robots play a minor role at the time of explaining recent worrying developments, for instance, I'm talking about job polarization or job losses or wage inequality. So in consequence, we cannot expect from policies focused on robot adoption or the regulation of the use of robots to have a significant impact on labor market dynamics. If we do this, there will be a risk of deviating public attention away from other more prominent causes, such as regulatory, etc. In relation to this, we do know that there is some people talking about the need or the convenience to tax robots, and our findings suggest that this could have a negative impact on both employment and economic growth, because robot use, as we can see, is associated with increased productivity, this is clear, and potentially with increased employment. Finally, it has to be clear that new technologies and also industrial robots replace tasks, specific tasks, not entire jobs. Jobs are bundles of tasks. So it is more likely for new technologies to produce changes in the task content of job, in the organization of the job. It is more likely this to happen than new technologies replacing entire jobs. So consequently, for the future, but also for the present, upskilling and re-skilling are going to be key strategies to have a workforce that is resilient and that is prepared to the changes in the world of work and the labor market. And that's all. Thank you very much. If you have any question.
Yeah, there were two questions in the chat, but I also see Dirk van Leden has his hand raised in order to ask a question. So, Dirk, I will give you permission to speak if you have a question for Sergio. You have to unmute yourself if you want, Dirk. Okay, maybe not. Dirk, if you find a way to unmute yourself, you're more than welcome to ask a question. We do have two other questions for you, Sergio. So the first one, I think this is related to the job increases in Europe, right? So the question is this job increase in Europe highly linked to reshoring? Or are jobs being destroyed overseas, but increasing in Europe when robots are applied?
Okay, interesting question. Well, I didn't say anything about this, but my role on this, I'm not one of the authors of the papers that I'm presenting. I'm collaborating with these people, but my role here is I prepared a policy brief and a synthesis report synthesizing all this information. So what I know these research pieces, and they are not assessing the impact of reshoring. So in these regression models that they are preparing, they don't introduce these variables. So I cannot say something clear about this. If you have more questions in relation to this, of course, here you have my email and I'm in permanent contact with the author, so I will be more than glad to try to find an answer.
It goes out to everybody. If there's one of your colleagues that can respond to that, it might be interesting for the attendees to hear that. I see Dirk. Have you unmuted yourself? Are you able to ask a question?
No.
Okay.
No. Do you hear me now?
Yes.
Yeah. Okay. Sorry. There was a mistake with my mouse. Excuse me.
No worries.
Yeah, okay.
Okay. So then we have another question from Ignacio. He's asked, has the JRC worked on some study about this recently?
Yes. Well, in fact, they have been working intensively on this. All the findings I'm presenting come from in the last here you can see these pieces. They are all coming. They have been prepared by colleagues in the GRC in the last year, so they are really fresh, still fresh. They have been prepared as working papers. Some of them are now under evaluation in some journals, but yes, it is a topic in which we are putting a lot of effort recently. I can share, of course, I can share the policy brief in which I synthesize all these results. If you are interested, please write me an email. We published this policy brief last week, so I'm glad to share it. And also all these references. These references are linked in the policy brief, so
Okay.
It is easy to find them.
Okay, great. Well, we'll have, as I mentioned at the beginning, we'll have the slides available for all the attendees in the email that we send out, but maybe we'll also add that policy brief in as well. So one other question. So has the JRC or EC some evidence of good practices by employees or unions facilitating the introduction of robots, cobots in some specific companies or regions?
Not for the moment. For the moment, the evidence we have is only the references I'm putting here in this slide. We are going to continue working on the topic, so maybe in the future, but for the moment, we don't have anything about good practices.
Okay. Great. Any other questions from anybody before we move on to Minna? I guess not. Perfect. Well, thank you very much, Sergio. Much appreciated. Very interesting information.
Thank you very much.
Great. Minna, I can give you the floor.
Okay, thank you. I will share my screen.
Great.
All right. So, hello all. My name is Minna Lanz and I come from Finland. Finland, I also represent the Finnish sort of a mindset and the contextual setting what we have here in the industry, same as in Nordic countries. So most of my viewpoints come from the fact that our companies do high value products with quite high labor costs, and the products are unique. So the focus comes from mass customization and personalization of high value added goods and services related to those. Like the previous presenter, I will also start with a little bit review on the industrial revolutions, which have been the driving force. So if we look from the production perspective, because at the core, my field is the production engineering, and I look everything through the goggles of value added or non-value added. So the industrial revolutions, while they might have been technical achievements, but they also contribute to the productivity. So the first industrial revolution, of course, the power generation made the leap on productivity. The second industrial revolution allowed us to move from personalized goods more to the mass production. And automation, if we consider that as the third industrial revolution, allowed us to take the giant leap on productivity. But as it is now, we have moved on to the fourth industrial revolution, which now focuses on the mass. Instead of mass production, we focus on the mass customization and even to the personalization. The fourth industrial revolution, more commonly known as Industry 4.0, has been quite good on the technical perspectives. So it's a really driving force for the communication and connectivity between the systems, interfaces and protocols. We have a lot of activities on defining that how we are sharing the data, what is the interface we are communicating between the smart systems, if we want to call them smart. Of course, we have to focus on sensors and data collection and somehow to share them to the platforms and show the KPIs relating to the productivity and the other things that what happens in the factory floor. Then, of course, the data sharing, regulations, and human centricity have come into the spotlight on the recent years. And this has been quite interesting. We are moving from the communication to the message that what we are actually communicating between the different automation islands. And little by little, these automation islands can be connected to each other. Of course, this has been quite good background for the robotics, human-robot collaboration, advanced robotics. I summarized some of the rising trends on human-robot collaboration. So the technical development has allowed us to create intuitive and multimodal programming environments. There is a lot of achievements and progress on this field, meaning that the users who are using the robots don't necessarily need to be the experts by themselves. They can focus on the tasks. They might be the task experts and not the experts on the robotics. So meaning that with these technologies, we could make the setup times, the non-value added time smaller. Of course, the zero programming is a quite high trend as well. So that can we change the work cycle by gestures, voice commands, or natural inputs instead of coding? Again, making the communication between the robot and automation systems more intuitive, more easier for the user. Then, of course, the immersive collaboration with different devices is trending now. I have particular interest on these topics, so that how we can augment the human, how we can increase his or her knowledge about the task at hand. Can we offer them on spot guidelines so that the task will be done more efficiently and more better from the quality perspective? And of course, then the context and situation awareness, so that how the system and the human communicate, how the human knows about the system, what the system is doing at each given moment, and how the system will get information about the human, because the human might do quite a lot of different things, not necessarily the right things, but something that might disturb the system performance in general. And this comes to the communication between the humans and the systems in general. So these are the very interesting scientific frontiers, what I could say. But I would like to step back a little bit, looking on that what is the industry point of view, so the reality check. So that as a researcher, professor, I like to dwell on the academic side. The robots are interesting. I like them personally as well. But if we look from the production perspective, the companies, they are still struggling on their daily lives. So the competitiveness is the key what they are looking. And it might not be the technology that solves the problem. What comes to the competitiveness is actually that how we are supporting the human to collaborate with the systems, how we are enabling the collaboration between the different networks, and how we are decreasing the non-value added time, because still that's the fact. From order to delivery, the value added time is between 1% and 5% for the good companies, and less for the less successful companies. At the same time, we have to notice that the SMEs are struggling to fully take on the emerging technologies. We have a lot of emerging technologies. In that sense, it's good that we get the prototypes and beta versions available for the markets. But again, if we struggle with the daily operations, the prototypes are not enough. They are not reliable enough. They are not productive enough. And the amount of technologies, the modules, what comes out of the markets is huge at the moment. At the same time, there are other challenges for the SMEs. We still struggle with the lack of visibility to factory floor. Most of the time, our systems are not automated or connected. There are manual labor along with the automation. We can get the data from the automation systems, yes, but from the manual operations, it's still hard. So we struggle with the low information quality and quantity. And also there is now that the AI is a rising trend. So the distance between the person and the system grows bigger, meaning that when we are utilizing the deep learning neural networks, we are not exactly aware, or most of us are not aware how the calculation goes inside of field of AI. So this comes to the question that do you trust the system? Do you trust the reasoning process which you can't open and which is not transparent at the moment? And of course, the SMEs struggle with multiple tools. There is a lack of information flow and connectivity between the systems. Then comes the fourth challenge. Slightly old picture, but this is the distribution of manufacturing at the EU. So Germany is leading, well, UK we lost, but Italy and France and Spain are the biggest manufacturers in Europe. And then we got look who are the people who will work in 2030 in these companies. And I would say that it's less people. Who are the engineers, this smaller number of people who can take up the new technologies, utilize the robots more efficiently. So it comes to the question that if the robots increase the jobs and employment, so where the people come from, it's not that the EU's number of people will grow. It's actually going to decrease in some of the decades. So this is one question for how we actually replace the workplaces with the robots. Slightly contradictory what the previous person said. I collected some comments from our local industry. So they confirmed that they are interested on robots, new technologies, but they struggle with a number of new technologies. There is simply too many. They propose that can we have field agents who will collect good ideas and pass them forward. On the education and learning, there is a need for a new kind of IT competencies and lifelong learning for both workers and SME managers. This is something what we are struggling at the moment, since it seems that this is not the fact, but it's indicated in a couple of the papers I read lately that while the trend is to lifelong learning for the SMEs in the manufacturing field, this is our target, we try to do that. The fact is that most of the re-educators or re-learners are young ladies with already having the bachelor or master degree. This means that these persons are not working in the manufacturing SMEs, as we know that there is a slight unbalance on gender in the manufacturing field. So the question is that how we are going to reach the SMEs and focus on the lifelong learning, how the people working in the SMEs will learn about the new technologies. Then, of course, on the business model side, we still struggle on the data analytics and data ownership. So who's going to own the data, how we are sharing, what is the fair trade between the collected data. And of course, the fast pilots was what the companies were expecting, hoping to see. So the general assumptions, if I would summarize some of my slides, is that there is a lack of working examples on how these prototypes behave on the factory floor, how we can make them more robust. Also, how we combine different technologies to fit to the need. And of course, slightly biased assumption number 2 is that the digital tools for the manufacturing at the advanced robotics, safety and cybersecurity challenges are relevant and interesting for the SMEs. Maybe because we asked that, are they interesting? So that comes to slight bias. But nevertheless, developing the skills and expertise is also challenging. That what are the technologies we should teach them and how? If I try to summarize my slides from the beginning, I come back to actually this same picture. And if we focus on the industrial needs, then the Industry 4.0 simply means that we are making the lot size 1 economically feasible. And now comes the connection to the digital innovation hubs. Our approach was for the Trinity digital innovation hub development. So this is short introduction to the Trinity. We wanted to create actually the society community for the robotics, industrial robotics and advanced robotics, IoT, cybersecurity. This was the demand from the Commission side that we need such community, and it has to be sustainable after the project runs out. And while we were considering that how we will make this interesting to the companies, we came to the realization that the examples, the working use case demonstrations are the key to show that what our technology, what the emerging technology, when we combine them, what we can do with those, and how the companies could copy and replicate them. So in the Trinity, we came up with 18 internal use case demonstrations arising from our collaboration with the industry. And the focus was on the technology readiness level 5 and above. Then we just started 19 new industrial demonstrations, more to show that what we can do, how the experiments can help the companies to test and drive their product development and production development processes. And of course, we are expecting 20 to 30 more in the next autumn. And what is the key for making these demonstrations interesting is also that how mature they are. So we are comparing them to the existing standards and technical specifications to show that what is the actual maturity level of these modules and technologies. So if we go deeper into the use case demonstrations, so the idea is that on the right hand side, you will see some of these small pictures. You can see more on our website, those use case demonstrations. They all are combined of technical modules, which have well-defined and documented interfaces. They will be openly demonstrated, and they come with the setup and training material so that somebody could perhaps use them later on. And in the end, we want to build this kind of a Lego brick wall that you can choose and combine rather freely different technologies to fit the purpose, what you might have in your factory floor. Then, well, from the Trinity perspective, what the digital innovation hubs should provide. It's not only the technical examples, but it's quite much more. So what you should expect from the digital innovation hub, you actually have to request, is that they link existing networks. They work on a regional level, combine regional hubs, and hopefully connect them into the pan-European collaboration platforms. Of course, these networks have to be sustainable, so they have to be alive at least 10, perhaps 15 years in order to make any difference. Of course, it would be nice that they will offer the centralized access to the relevant update knowledge and networks, might offer catalogs and marketplaces, training material, hands-on deep dive workshops so that you can actually visit the laboratories and test and try these technologies. Also to provide access to the labs, pilot lines, field labs, prototyping areas, what are hidden at the moment inside the companies and the universities. And perhaps provision of funding through open calls is something what the digital innovation hubs can do. Then, as you know, that there are many of these digital innovation hubs or baby hubs which are now forming. So the question is that why so many? The rest didn't fit on my screen, so I only selected few of them. There are at least a dozen more that came into my mind. But the fact is that they are regional networks. We have to build the regional collaboration before we can jump into the pan-European collaboration. And the fact is that why we have so many thematic areas is simply the fact that one size does not fit all. So these have thematic areas and focus groups. And I think that's one of the strengths of the number of digital innovation hubs. Of course, they have to be existing long enough that you know that what these actually offer. If they are here for 4 years, then it's no use. You learn about them and then they are already over. Because building of collaboration takes time and it takes trust before it's valuable and cost efficient. But all in all, what we can do to ensure successful business in Europe, from my perspective, we can increase the product quality and production capacity by robotics. That's for sure. If we want to make production more predictable, then the automation is the key. Of course, if we want to make it more reconfigurable, then we need a lot of more ICT solutions for that. Of course, we can shorten the overall production time with the ICT and AI technologies. So the digitalization is the second pillar. And the third one, the benefits from the industrial ecosystems. Europe is rather small and the SMEs in each country are small and unknown. But if we form industrial ecosystems that allows companies to share the resources, maybe answer together to the larger customer needs to provide the full solution. Of course, the lifelong learning support from each others is something what has to be considered in future because we don't have that many resources. We have to share and we have to learn and we have to re-educate them together. And hopefully we can shorten the supply chains and the time that takes from the order to the delivery. And that was my speech. Thank you. Any questions?
For you. This comes from Amanda. How were these demonstrators set up? What was the process to choose them, funds to develop them? Maybe it's a little bit more than just one simple question.
So now you can see my screen back.
Yeah.
So the first set of industrial demonstrations, they come from our laboratories and prior collaboration with the companies. So it was advancing existing ideas to the technology readiness level 5 and 6 mainly. The 19 new ones came through open calls. So we had 116 proposals and we selected 19 of them, which just started in the summer. And this was through the Cascade funding opportunity. And this is something what we will repeat on next Valentine's Day. So next year, Valentine's Day, we will open the new call for the 20 to 30 new demonstrators as well. Okay, there were some other questions.
Were there specific criteria in choosing them within those open calls?
Yes. First one, it was the impact. That was the greatest. So we had the, of course, it's the technical quality and the idea itself, but the biggest one was the impact. Then came the consortium and how you are deploying the resources. So actually 4 categories where the impact was weighted by 2.
Okay.
And it was all of the applications were evaluated by 3 external evaluators.
Great. I also see a couple of the questions here that are popping up now. So one has to do with the competition between China and the EU. So is there an idea how this is organized in China? So do we have an advance, or do the Chinese have the upper hand?
So far, we still have the upper hand on if we focus on the high value added products. But the Chinese, they are running fast. So the deployment of new industrial robots, they are deployed in China. So pretty soon they will move from the mass production to the more mass customization, smaller batch sizes, and finally the personalized items. So that is expected. So far, we can still be more flexible and more cost efficient. The robots are, the price of the robot is same across the globe.
And is there a sense of, say, the collaboration between, I personally don't know if there are kind of digital innovation hubs within China as compared to Europe, or is it set up differently, if you have that answer?
For me personally, no, because we agreed that my colleague Jyrki Latokartan, who is also in the call, goes to China, and he did. And based on his comments, he could write the comment here as well, is that there are some activities to build similar innovation hubs. Of course, they have now focused on reducing the emissions. So robotics is without doubt one of the elements to do that as well, and focus on the high value products.
Okay, great. I see one last question here. So how do you collaborate with other digital innovation hubs on manufacturing? Example, there's one here, MIDIH.
Well, at this moment, we know about each other, we collaborate with each other, and now we are actually preparing from the Trinity side that how should we submit our results to the MIDI platform. This is under the discussion now. Mm-hmm. And of course, will the MIDI then, if we are building or extending the marketplace and digital innovation hub, how we could include their results also to our side? Can we somehow harmonize our platforms? That's under the discussion right about now. Email came a couple of days ago, and now we have to reply on it.
Great. Another question just popped up. What is the size or order of magnitude of these demonstrators as regards to the investment?
These are more on the prototype side. So when we opened the call, the instruction was that the companies or the consortiums have to have a roadmap, they have to have a vision, and the Trinity can support for the prototyping phase. And the maximum grant size was 300,000 for 1 year project. And that, of course, you could include some of the equipment and depreciation of the equipment. And the expectation was that once they are mature enough, that the technology has been tested, it will be deployed to the industry. And it depends. Some of these demonstrations are from the system integrator point of view, and some are from the manufacturer point of view. So the impact is in respect to those actors. But yes, there is they defined the KPIs, and hopefully we can publish the expectations quite shortly.
Great. Great. Well, I don't see any other questions here, Minna, so I will thank you very much for your presentation.
Thank you.
I will pass it on to Ger. So as I mentioned very briefly at the start, we're starting with kind of the macro or kind of the oversight view and moving down into the more specific or to the more tangible. So Ger, I can pass it on to you to discuss about the SME support activities that your organization is doing.
Okay, very interesting, Minna and Sergio, about the different technologies, robotics, digital technologies. And it's a very challenging era, I would say. The European landscape is constantly changing. Trends towards smaller lot sizes, more flexibility, more agility in production systems. And last but not least, the last COVID-19 pandemic has also urged us to reflect on global value chains and to see how we can revise them and see if they can't be shorter. But all in all, the European economy will survive if we focus on high value added, as Minna said, and we need to have very flexible, agile, digital and innovative manufacturing systems. I'm going to talk a little bit on the COTEMACO project, which is an Interreg Northwest Europe project. But the majority of my presentation is on the support program, the SME support program, which is the core of the project and which we are focusing now in the last year very much on. And in the end of the presentation, I will also show you some example of 2 of our field labs, which we have established in view of the project and which are really necessary and key to attract the SMEs into the project. As already said, it's a Northwest Europe project, so financed by Europe partially, and it focuses on collaborative robotics and digital technologies. And yeah, my background is an industrial one. I used to work in the industry for many, many years. So I try to, and I also tend to look at things from an industrial point of view, and especially from an SME point of view. And when you talk about collaborative robotics and digital technologies, we did a research, kind of a survey end of last year. And then we noticed that these type of technologies are still really far from the SMEs at the moment. So the question is, how can we get these SMEs to really adopt these new technologies and to really use them and change their business models, their products and their processes with these new technologies? How can they jump on that train? In the project, we combine 4 different regions. There's a region Lincolnshire in the eastern part of the UK. 25% of this region is focused on food manufacturing, the food manufacturing chain. And I must also say that in this project, we focus on 2 different application areas. The automotive manufacturing / flexible assembly, but also the food manufacturing. And we see in the food manufacturing that collaborative robotics and digital technologies are not really widely adopted yet. So in Lincolnshire, there is a vast food manufacturing industry. And these 2 partners here, the Lincolnshire, the University of Lincoln and the Lincolnshire Enterprise Partnership, they focus on food manufacturing and trying to get the SMEs in that value chain adopt these new technologies. Then there's the region Brainport in Holland, where we have food tech Brainport and high tech NL. And you will see in this project that we try to combine more technology-oriented partners with more business-oriented partners. I will come back to that a little later. In Germany, there's the region of Saarland, where we have SARES, the innovation agency in Saarland, and ZEMA, the technology organization. And last but not least, in Flanders, we have Flanders Make and the Chamber of Commerce in Limburg. Also Flanders Make as a research and technology organization, and the Chamber of Commerce as the business-oriented organization. And together, by a combination of these 4 regions, we try to create kind of a connected ecosystem of technologies, field labs, but also companies, value chains. Okay, so far, a very brief presentation on what the project is. It's will be finished end of next year. So we are now in more or less in the final stage, and we are now really working with companies to help them introduce new technologies, which I will tell a little bit later. When we talk about helping companies to introduce these new technologies, we talk about the SME journey, which you see in the left-hand top corner. Now, the SME journey consists of 7 different steps in this project. I'm going to close this here. And the program is really tailored to SMEs. It's very flexible. It tries to lower the threshold. The administrative process of a company joining the program and getting the support from the company, from the project partners, is very low. So there is no big project files to be made or to be filled in. Companies can make themselves known and can apply to the project via a website which we have created, a Robotics website, which you see in the right bottom corner. But the practice shows that the regions and the partners in the regions, they really have to reach out to companies to get them involved in the project. So after reaching out to the companies and they apply to the Robotics website, we mainly do that via bilateral contacts, via events, workshops, technology days, etc., etc. And then the first step is to do an initial assessment of the SME. We have to define whether the SME already has a certain maturity of the technology adoption, or whether it's still in the early phases. And we also have to see whether the company is eligible. This assessment is done by the project partners in the region, because we think that proximity is very important. So the regions reach out and do also the assessment. And after the assessment, we can decide together with the company how to proceed further. And then you see there is 2 different options. Companies can apply for the full program, which starts with an incubation phase and ends with an adoption phase, where the incubation phase starts with a training and a coaching sessions in one of the 4 field labs which we have established in the project. And I'm coming back to that a little bit later. So in this incubation phase, the next step would be that we join the company and we get the company to visit one of the field labs in one of the regions, the relevant region, that the company can get a training in that field lab. There are specific training modules being developed in the different field labs. They can get connected and get acquainted with the different technologies, and so the threshold is lowered to adopt them. There's also an option to skip the incubation phase for companies which have a higher maturity level. And these companies, these SMEs, and there are some of them which do that, they can enter immediately in the adoption phase. And we call that a fast track or the super fast track. So companies which already have a certain level of digital or robotics maturity, and I will show an example in the next slides. We immediately try to connect them to the adoption phase. We try to make an elevator pitch with them, if necessary, for the higher management to get the funds available. And the core of this adoption phase is that we make, together with the company, a feasibility study. So if they have a certain use case, we make a feasibility study for them and with them, which shows the company which technologies to take for their specific case, how to implement them, how to adopt them, and also which integrators to use in their specific case. And in the end, we also try to make a business and investment plan, where we try to show the companies where to get the funds for their implementation of the technologies, and also how to really make business of these new technology, because that's what's mainly lacking in the companies. They know, they have an idea of the technology, but how to really make money of that, that's a different step. And for each of these two phases, we have a funding of 10,000 euro available in the project, which is mainly used via a voucher scheme and is used for travel and training program in the field lab, but is also used to make the feasibility study and also the business and investment plan. So our experience so far is that it's an easy to manage program, and it's also easy to execute, looking from an SME point of view. And as already said, the experience learned that the project partners, we really have to reach out to companies, but once they are on board, we see really nice testimonials of companies which are very confident and satisfied with the approach and with the support. So in order to reach out, in Flanders, for example, we organize regular technology days with SMEs. So that's a collaboration between Flanders Make and the Chamber of Commerce, the business partner. In these technology days, companies can explain their needs, they can explain their case if they have it. And in this way, we can immediately reflect in a bilateral way to these companies and try to create a bond between the SME and the project, and try to define the next steps immediately. I must say that physical meetings are very essential. So we have been struggling a lot with the latest COVID pandemic, where we could not really visit companies and see companies and people in the company face to face. So that's a bit of a problem at the moment. But this bilateral approach really works very well. So in total, the project is now working and supporting 20 SMEs approximately with this voucher scheme, and the intention is to increase that level to a number of 50 SMEs by the end of the project. Now in the following slide, I will present a concrete case of a project which we have done in an SME in Flanders, and the company is called Aminolabs. It has been recently concluded, this project, and Aminolabs is a company who produces food supplements for the sporting business. So anyone who rides on a bike or does jogging or running, you know that the powders or tablets in your water, in your drinking water, you can add them in order to have more energy, or ride faster or longer, etc. So Aminolabs produces these powders. Looks like this. They come in big containers or small containers. And it's more like a mixing, filling and dosing process, which Aminolabs have. It's a very small company in SME, but in their market, they are market leader at the moment. So what we did in Aminolabs, you see here the process. The process, in fact, is highly automized, but there's 2 steps at the end of the line, which are really manual at the moment still. In every container, there needs to be a scoop, kind of a spoon, which you see below, 8 different types of spoons, which needs to be inserted in the container after the powder has been inserted. And also the lid needs to be screwed on. And at this moment, there's 2 operators in the line doing that full time. So Aminolabs approached the COTEMACO project, approached Flanders Make, and they wanted to first automate the scoop insertion in the line. And when that was successful, they would also like to automate the screwing of the lid. Well, this was quite challenging because the number of the scoops, as you see here, and there's a lot more different scoops, they are different in size, different in type, etc., different in circumference. And the system needed to be very, very flexible. So that was kind of a challenge. And so we worked with Aminolabs to do a feasibility study and to provide them with a type of automation in their line to insert the scoops. This is what it looked like in the end. You see the conveyor belt, the gray belt at the right. So the containers, they start from the right bottom corner and they move to the left top corner. And they are stopped at the robot. So we use the universal robot, and the laser sensor stops the container at the robot. And then the robot picks up the scoops, the spoons, which are lying in the SU cube. And the SU cube, that's a vibration plate where always enough scoops are in, and the robot picks up a scoop and puts it in a container. It looks like a very simple system, which it is, and it should be, because Aminolabs is an SME and not really very experienced with robotics. But still, it's a very smart system because there's a camera on top of the vibration plate. It counts the scoop. It's also trained to see the orientation of the scoop because they must be oriented in a certain way. And it communicates to the conveyor belt from the scoops and also to the robot. And it gives signals to the robot and the conveyor belt to either move and insert scoops in the container. So this is an example of one of the 20 SMEs which we are working with, and every region has different examples of SMEs. Aminolabs is currently in the process of acquiring the funds for this system, which cost about 100,000 euros. So considering the fact that it's now being done by one human labor full time, you can easily calculate the payback time. Now so the case Aminolabs, in the next slide, I'm going to focus on the field labs which we have established in the project. And as Minna already talked about demonstrators, we really think that for companies, seeing is believing is very important. So we very much cherish the fact that we need to demonstrate new technologies first, because companies can start looking to the adoption of new technologies. I would like to give two examples of two different field labs in the region. Let's start with the Flemish field lab. It's called the Make Lab. It already was there when we started the project, but we adopted it slightly to the scope of the COTEMACO project. Now, the Make Lab basically is an Industry 4.0 on wheels. So we thought about how can we bring all these new technologies to the operator on the shop floor. And then we realized that Flanders Make, being a research and technology organization with 3 different sites all across Flanders, that these operators would never visit the Flanders Make sites, but we needed to go to the companies to demonstrate the technologies and to let the operators really experience these new technologies. So we built them in a trailer. And it's, as I said, a mobile research lab. It's a fully connected infrastructure, a living lab. And we use it to go to companies and to get the operators acquainted with the technologies. We organize training sessions, we do feasibility studies, etc., etc. So this lab is ideally suited for the COTEMACO program. And it also, and we noticed that now that it also very much lowers the threshold for the companies, because it's very easily accessible. You can hire it. Companies do have to pay for it. It's not really a free lunch, but it's a really open infrastructure environment. This is what it looks like from the inside, at least part of it. You see there a collaborative robot from KUKA. This is assembling a part of a compressor. And this is a training session which we did for one of our companies, where we demonstrated the technology of collaborative robotics. And it really worked. The operators are always very enthusiastic, and so is the management. So in the picture, you see operators engaged in this training session, and they can also assemble themselves part of the compressor together with the robot. This is an example, and that's also my last slide of the Dutch field lab, which is focused on food manufacturing. Also there you see a universal robot, collaborative robot. And also in this picture, you see a training session with different people from companies joining the field lab and experiencing new technologies. Also in the UK, in the area of Lincoln, and also in Saarland in Germany, we see similar field labs. that concludes my presentation. I hope I have been able to give you an overview of the project and its support program. And to my experience, these type of programs, which work basically with cascade funding, as Minna also mentioned, are relatively easy to use support programs, which really lower the threshold for companies, and which really can be of added value to increase the level of technology in Western European manufacturing. Thanks a lot. If there are any questions, I would be happy to answer them.
Great, thanks, Gerrit. Yeah, we do have a couple questions here. First is, I think this is referring back to the SME journey when you were talking about one company skipping the phases. So this question is, how do SMEs skip this initial phase?
Well, the track which a company is going to use, either the full track, so the full program, or the fast or super fast track, that's determined in the initial assessment. So when we go and talk to the company and see what the business case is and see the level of maturity of the company, we decide together where to start the program. And if the company wants to start, for example, directly with a feasibility study, we immediately do that. So we don't ask them to join one of the field labs. We don't ask them to go through a training program. They can do that if they like, but if it's not necessary, we don't do that. And we immediately start then with the feasibility study and with the business plan. So it's very flexible and easy to adopt.
Right, and I guess that makes it very easy for any SME to prefer to go into one place or another within this journey, right? If they prefer to go into one place, then it's easy and flexible, as you said.
Yeah.
I have another question here. What has been the employee experience during the program? I would assume this means like the technician or the person actually working within the process.
The employee, I assume that it's the employee in the SME. Well, we have worked with, and I think it refers to when we try to automate a process that the employee is skipped. Well, when we talk to employees, and we do that not only in the COTEMACO project but also in other projects which we run, is that the insertion of the scoops in the Aminolabs case and also the screwing of the lid, those are very dull processes. And in many occasions when we talk to employees, they are very glad that they could get rid of it. They have to be retrained, of course. They have to pick up other tasks in the process, maybe other tasks in the company. But employees are really not very fond of these type of really repetitive process steps.
Right. I do have another question here from Sergio, actually. So he's asking, and maybe this goes a little bit outside of the scope of the discussion today, but I think it's interesting nonetheless. So do you have any data, either quantitative or qualitative, about the impact of the projects or programs, specifically referring to kind of productivity or employment, sales, etc.?
I don't think we have done that yet. Certainly not in the COTEMACO project because it's a little bit too fresh. So I would say the answer is no, Sergio. We don't have really quantitative data on productivity increase.
Okay. Great. Well, thank you, Gerrit. That seems to be like all the questions that were asked. Thank you very much for the kind of more relevant, tangible presentation that you gave. I think it gave a nice kind of completion to what we started off with a little bit more of the kind of macro or the overview presentation from Sergio. Are there any other questions regarding kind of the future of manufacturing or any of the other things that were discussed by the presenters today? We have 1 to 2 minutes left, so happy to take on any final questions from anybody. I see not really. Okay. That's fine. So I think we can end here. We're on time. I want to thank everybody for attending. Thank you again to the speakers for bringing in your insights and the information that you were sharing with everybody. We do have some contacts for people that are interested in the COTEMACO project. As Ger mentioned, he is working in the Flanders region. We also have contacts with other partners in the other 3 regions. So if you want to get in touch, you can get in touch with Ger, but also feel free to get in touch with us. We do have one question here. Are there larger companies that have interest to support this initiative? Ger, I don't know if you want to respond to that, or?
Yes, there are. There's also large companies. In fact, in the project, we have a continuous discussion on, is this company an SME or is it a large company? And basically, large companies we cannot support in the project. But there are large companies which are certainly interested. Also, when I showed the example of the Make Lab, the mobile infrastructure, we work with lots of large companies as Atlas Copco, for example, which are very interested in this mobile infrastructure and the support program we can give here.
Yeah, maybe one thing I can add to that here, which has been, I mean, we work closely on this in conversation about once the project has actually ended, once the funding period has ended, there is obviously an opportunity to have larger organizations, larger companies come into those field labs and get the same sort of support, but it's just not possible during this funding scheme because of the limitations of the EU funding, of course. I think that's something that other partners have been interested in as well. We have another question. You meant involvement of OEMs or robotic integrators? I believe that's for Alan, actually.
When I talk about the, let's say, the interest of large companies, we mainly talk about end users. So that's companies who want to integrate robotics in their manufacturing process or digital technologies.
Yeah.
But what we try to do is when we do a project and we have a company which is interested, we try to immediately connect the end user with a potential integrator or integrators so that we can do the feasibility study and then also can look at the real integration on the shop floor. So connecting different organizations together, connecting different partners in the value chain is an important part of the support. Yeah.
Okay, great. I see we have one question, and I think this will have to be the final one as the time is already up. Is there an interest also to get other technology providers on board?
Technology providers, I would say on board of the project. I think that's, correct me if I'm wrong, Marc, but I think that's quite difficult because the partnership is running and the project is well underway. But we try to in the project we are now looking at the long term, how to sustain the partnership after the project has ended, and then I would say that it certainly aims to be a kind of an open platform where we can support multiple companies and also use different technology providers or integrators.
Yeah, I will add just to that, we are building an ecosystem within the Northwest European part of Europe, of course. So if you are a technology provider, do get in touch with us as we could facilitate some sort of contact with other relevant or interesting entities afterwards. We can kind of have you in that pool of the extended ecosystem that we are developing. I think that should do it for the questions. I don't want to keep people beyond the time that people have already allotted. I just want to repeat from what I said at the beginning. We will have a recording of this sent out with the PowerPoints in the next few days, maybe early next week. And I think with that, I just want to thank all the speakers, Minna, Sergio, and Ger, to come and present your information on the future of manufacturing within Europe. Thank you very much to all the attendees that joined, and we'll follow up with that email and any kind of communication activities that can be done after. So thank you very much, everybody.
Thank you very much.
Thank
you, Marc.
you.